So today we are to discuss the order of operations, also known as PEMDAS, among many other names. So why do we have to have an order of operations? It's because of conventions. Of course, we need to standardize things because we need equations to send stuff to other places like the moon or other countries. Equations are very important in our even our daily lives. So we need to have a convention, kind of like the order of adjectives, which to be fair I haven't memorized yet in preparation for the college entrance exams. But yeah. It's basically so what they say isn't ambiguous so other people will understand what we say every time in terms of math for the order of operations. So the first priority is the parenthesis or grouping, or more specifically, what's inside them. So this includes functions like sine, square root, absolute value, which is basically take away the sign, and fraction bars. But most commonly, the parentheses or grouping that you will see are the parentheses, the brackets, and the braces. So if there are parentheses, brackets, and braces, you must do the parentheses first, followed by the brackets, followed by the braces. The second priority includes the exponents and the roots. So this includes the square root, cube root, and other higher order roots, and the square, the cube, and a lot more, including the fractional exponents, which are just roots. So here, if two expressions have the equal level, you have to operate from left to right, which is kind of unfair for those people who write from right to left, but that's convention, I guess. So sometimes you might encounter stack exponents. So if you see them, you must evaluate from top to bottom. That is because of the laws of exponents. So the expressions on the left and in the middle are equal to 2 to the 81. But the expression on the far right is 2 to the 12. Now for the third priority, this includes multiplication and division, which are of the same level. So you have to operate them from left to right. So this is where most of the confusion comes from because of how many signs can be used to express multiplication and division. So we have the parentheses or even brackets and braces. We have the multiplication dot, we have the asterisk, we have the multiplication cross. That's only for multiplication. For division, we have the slash, the fraction bar, and the division sign or obolus as some might call. Now for the easiest part, you need to add and subtract last. So you evaluate them from left to right if you see multiple plus or minus left. But your goal is to basically remove all of the multiply, divide, exponent, stuff like that, and leave just plus and minus in the end. Now it's time for examples. Let's start with a simple example first. So as you can see, there are two layers of grouping, but we need to focus on the parentheses or the most inner layer first. In the most inner layer, there's multiplication and subtraction, but we do multiplication first. So let's do that. 5 times 2 is 10. After that, we can do 2 minus 10, which is negative 8. Then what we can do is turn that minus negative 8 to plus 8. Because subtracting a negative number is like adding a positive number. Then we add 3 and 8. Then we get 11. We can square that to get 121, which is the final answer. Now let's go to a more complex example. First, let's do 2 plus 1 equals 3. Then square it to get 9. Then now we see that the fraction bar is acting like a grouping symbol, like some parentheses. So what we do is first cancel out the 24 over 12 to simplify it. That is 2. Now we multiply 2 by 4 to get 8. Then finally we divide to get 80 over 8 in lowest terms, which is 10. Then finally we add 9 and 10 together to get 19. Now let's go to a bit of a more controversial example. As you can see, there are a lot of multiplication signs used. We have the dot, we have the parentheses, we have the asterisk, we have the times symbol. So what we do is convert all of the signs into times, because you have to be consistent with your multiplication sign. At most you can have the parenthesis and the times sign. There we go, much better. Now we do multiply the 4 and 5 to get 20. Then we do the multiplication first before subtracting. 8 times 3 is 24, and 3 times 20 times 2 is 60 times 2, which is 120. In this case, the multiplication signs in the 3 times 20 times 2 can be rearranged according to the commutative property of multiplication. Then we do 24 minus 120, which is just the negative of 120 minus 24. And that is negative 96. Thank you, everyone. So, a quick backstory. I was asking one of my former teachers about common misconceptions made by teachers, and she said that geometry and a few more things. But I think one of the most confused topics ever is PEMDAS. And there are a lot of debates on the internet about this topic. So I decided, why not make a video to give a lot of people street cred on the internet. And by the way, I'll try to upload some more Beyblade content now that one of my YouTuber friends has more Beyblades. So yeah.